All right, we are doing 29 for day 2. So we're starting by turning this into one fraction. Any questions on getting this rewritten? I'm going to erase what I have and leave. Here is essentially the function I'm graphing. Let's talk about if anything cancels out. X plus 1, I sort of see it on the top or bottom, but it doesn't cancel out because the x is negative on the top and positive on the bottom. So that doesn't cancel. If I try to factor out a negative, then it's going to be a negative 1. So there are no holes. Vertical asymptotes. Look at your denominator. I'm going to graph as I go. You can do whatever you'd like. Do I need to put a star by either one of these vertical asymptotes? No, we only put a star if it's repeated. And that star means both arrows are going to go the same direction. Charlie, what do you think about horizontal asymptotes for this problem?
5 plus 0.
Yes. The denominator is x squared. Numerator is x to the first. The bottom degree is bigger. 5 equals 0. Did your work and make sure your work is neat so that I can follow it if you make a mistake, because there's a lot of work. Any questions on the work so far? Intercepts, asymptotes. Raise your hand if you want a little more time. So I plug in a 0 for x. So I put a 0 here, a 0 here, and a 0 here. So my numerator was 1. My denominator was 3 times 1. All right. Don't erase yours. I'm just making more room. Remember, we do the outside parts first. You can kind of tell this far right section. We can kind of do that first. So we know it's going to, I'm going to have to connect these. Is it going to go back down? No, it never does it. It never has a jagged edge of any kind. It's just one continuous up or down curve. So that's not going to happen. Is this going to hit here and then approach above it? No, because then it went right back up. It's not going to. That is not a curve that went down and then came back up. You can, if you want, plug in a positive number. Sometimes I write positive, so I know what I'm doing. So imagine plugging in a positive number here, like 10. So it would be negative 10 and 1, so that's going to be negative 9, or negative. If I plug in 10 here, I get 13 and 11. Is that going to be positive or is it going to be negative? Negative. I don't even care what the number is. It's going to be negative. So I can connect it. I wouldn't require you to plug in that point. You can touch a horizontal asymptote. You can touch horizontal asymptotes. You can never touch the vertical asymptote. Let's do this first section. Let's see what's happening at 10. Because I can't touch this, because there's no other x-intercept, it's either going to be this or going to be this. That's the only option because I have no more x-intercepts. So let's plug in, let's say, a negative value, like negative 10. So a negative, plugging in a negative is going to be a positive. Negative 10 and 3. Negative 10 and 1. That is positive. So the only way it can go is this curve. Questions on those? Your outer curves will always be like this or like this, something pretty basic. Your inner section, if there are 3, this middle section can look like what? It can look like a U or an upside down U or like an x cubed graph. Those are your options. So let's look at our arrows. This arrow is going up. So that means on the other side of the dotted line, the arrow is going down. This arrow is going up. On the other side of that line, it's going down. Can you tell what shape it's going to be? It's going to be a U. I don't care if your U goes like this or if your U goes like this, but your U cannot touch the x-axis because we've already found the x-intercept. So make a U-shaped graph. All right. I will try to do the next one without talking. Let me know if you have questions as we go. So try number 4 completely by yourself, please. If you want to check the function before you get too far, you could do that. Okay. So you don't have any information over here. You just want to plug in like negative. Negative 10. So I know what you're doing. Okay, so plug in negative. So I plug in negative 10 here. That's negative 20. 20 over. Yep. Yep, so it's going to be negative. So at negative 10, your value is this. So put a little dot. Okay. So since we don't have any more x-intercepts, this thing can't come up, right?
Yeah.
So it's got to go down. So now you've got this curve here. You can see up there, I didn't actually plug in a 10, I just plugged in a negative number, but you can plug in a number, just negative.
Registers.
Same thing there, yep. Okay, so this arrow's going up. So on this side of the dotted line, the arrow has to go down. It's always opposite unless there's a star by it. So here's like a train track or road. This guy's going north, this guy's gotta go south, so put a down arrow right down there. Yep, you gotta connect them, there you go. So over at 10, it's positive, yep, so it's gonna be that kind of here, yep. Then you're gonna have to do the middle part, just kind of look at your arrows. This arrow's going up,
So it's just like
so it's gonna have to go down here. So, yeah, just try to make it close to this line. And with this dotted line, the arrow's going down, so this arrow's going up. Oh, you just connect it. All right, so here is that side, here is this side. If this arrow is going up, on the other side of the dog line, it's going down. This one is currently going down, so on the other side, it's going up. I have to connect those arrows and any other dots that are in there. Oh, so kind of look kind of like the x cubed graph. There you go. If you're working on homework and you want to check your work, you can get a graphing calculator, type it in y equals. Just know you can't use the calculator on the quiz. Your homework is numbers 3 and 4 of the homework. I think your packet has a day 3. We're not doing a day 3 this year. There's extra practice if you want.